I'm Mike Bernhardt for the Exascale Computing Project. I'm here at the studio at Oak Ridge National Laboratory today with ECP Director Doug Kothe. Doug, thanks for joining us once again.
You bet. My pleasure, Mike.
So, very, very busy times, very exciting times.
Yeah.
We're now more than halfway through the year. Anyone following the project can see that there's a tremendous amount of momentum coming through. But let's start off with one big announcement made recently, the ECP organizational change that you just made. Tell us a little bit more about that.
Yeah, so we recently named Lori Dyson from Lawrence Livermore National Lab as our deputy director. Lori is fantastic. She's a leader in the field. She's a great team builder. She's also a great applied mathematician. Her track record speaks for itself. So Lori is going to be able to jump right in and contribute very heavily as deputy director. And she's not really, I don't think, going to act as a deputy in the way people might think. She's going to help us make key decisions. She's going to get down into the technical details. We're going to give her some pretty meaty responsibilities. And so she has the respect and track record both on the Office of Science side and NNSA side. So we were really excited that we were able to convince her to join us. She has lots of other opportunities, as good people do. So we're real excited about having her part of the team. Going to make a real difference for us.
That's awesome, and she's got the multi-lab experience as well, which I think is critical for this project.
It is. I think she has a wide perspective that doesn't reflect her own institution. Lawrence Livermore, a key NNSA lab and a key contributor to ECP, but she's also got a broad perspective. I mean, her experience in running, well, she's been a institute leader for many years in the DOE Oscar SIDAC program. Currently or more recently led the HPC for Manufacturing and HPC for Materials program. So we were really lucky to convince her to join us. Obviously a tough decision because she's such a key leader in other areas. So couldn't be happier for ECP moving forward. A really key addition.
It's awesome. And as noted in the announcement, she's replacing Stephen Lee, who's retiring from Los Alamos, and she's got some pretty big shoes to fill. He made quite a contribution.
He did. Stephen, close personal friend too. Really behind the scenes, chose to really kind of stay behind the scenes in ECP. I don't think people really appreciate what he did. Rolled up his sleeves and would do anything I asked or anything he saw that needed his attention. Basically, a deep expert. Really miss him already. So Lori does have tough shoes to fill.
Let's move into one of the first highlights that I wanted to kind of capture for this update. We just recently made the announcement about the ExaLearn Co-Design Center. Can you tell us a little bit more about that?
Yeah, we're very excited about it. So we felt like in ECP that there were certain requirements gaps we weren't fulfilling, and one is to look hard at machine learning in particular, and where in this landscape are there gaps relative to DOE mission need. And we asked a group of experts from 8 labs. The DOE system is 17. Frankly, there are people, this is a very hot area right now. There are experts across the landscape from the point of view of institutions. But we looked at, in particular, at 8 DOE labs, and we asked a group of experts to come together and essentially give us a plan for how they would address some of these key gaps. So this is the Co-Design Center, and that they're really going to have a line of sight to multiple applications in the ECP portfolio, and probably just as importantly, work closely with some of the DOE experimental facilities. There's a lot of data coming off these facilities. Scientific images, I would say, probably are top of the list, from light sources, from neutron sources. In particular, we think a scalable, adaptable machine learning environment will really help us get better return on the data. So this co-design center called ExaLearn is being led by Frank Alexander from Brookhaven National Lab. Frank is well known in the community. He's a team builder. He's a leader. He's very deep in mathematics and AI, and I think he's going to really take this effort forward. I'll just add one more thing, and that's what we expect out of co-design centers are not just best practices and guidance for applications that need to kind of converge with machine learning to improve their workflow. We expect a software environment and real products that'll be able to interoperate with applications or actually be the application itself in the case of, say, working with an experimental facility. So this team is just standing up. I don't even think they've all received their funding yet. So we've asked them to make the rounds with our Department of Energy sponsors in September to talk about their plans and get feedback on how to refine their plans and then move out fast. So
Okay,
we're very excited about that activity.
Exciting and timely. So
Yes.
that's a good one.
Yes.
So yeah, the next one now, this one, Doug, it's received a lot of attention from the HPC media, the public press and so forth. And so based on that, I mean, I know it's really important, but tell us a little bit more. Give us your perspective on the Software Technology Capability Assessment Report.
Yeah, I think not only a yeoman's effort by Mike Carew from Sandia and Jonathan Carter from Berkeley on the part of actually putting this together, but I don't think it's ever been done to actually have such a comprehensive tour de force of software technology. Essentially, the entire software stack kind of being summarized in one report. So it represents the result of a sort of ECP from a project point of view, formal assessment and review of our activities. So in a sense, it encompasses all the software technology focus area efforts. The write-up was really meant to summarize, frankly, it's 55 or 56 separate team projects that are summarized in this report. And the teams consist of 5 to 20 researchers in DOE, academia, and industry. And they're putting out kind of collectively order 90 separate products. So this capability assessment report assesses the activities associated with these 55 or 6 projects, the associated 90 products coming out. And probably most importantly is not just the status assessment of status, but where are they with regard to moving forward in the next 3 to 4 years in meeting our requirements, ECP and DOE requirements. So there's language in there about your plans, your milestones, your line of sight to applications. How are you going to help us meet our key performance goals? And for the software technology products, that's impact goals and metrics. And Mike and team have thought a lot about how to measure software technology products. And so each product has a separate set of impact goals and metrics. At a high level, it's are people using my product? Are they deployed on HPC facilities? Are applications using my product, and are people better off? Are the apps in the facilities better off for those products? So this will be, in talking to Mike, a annual, if not semi-annual activity to update this report. And so, from a project point of view, it's a direct. We have a direct view into how are we doing, and are we on track? Are we going to meet our metrics? But from a community point of view, it's a one-stop shopping for all the technology. People can go see that report and go, okay, that's something I really need, or that PI I need to talk to. So it's a tremendous outreach service as well. So I'm very excited about what Mike did. Really a tough effort, but we're very proud of it.
And getting some great reviews.
It is, and deservedly so. Again, I think that's one unique aspect of ECP. We're bringing together all these teams in one place and having a kind of group of senior leaders assess the state of the software stack, and it really is quite a remarkable piece of work. And we commend Mike and his leadership team, but also look forward to the revisions of this report as we move forward.
Now, we recently started featuring some of the project highlights on the ECP public website page, taking some very deep technical discussions and trying to repurpose those so that they make sense for a broader audience. And the first one that we decided to focus on was the ExaSMR. SMR, of course, standing for small modular reactors, an area that's very near and dear to you.
Yes.
Maybe tell us a little bit more about the ExaSMR highlight that we just recently featured.
Yeah, so very, very exciting for not just that project, but for the applications in general in ECP. And there are 33 projects in the application development area in ECP, and 25 of them are really working on a code base, moving it forward to go after a specific problem. So the application teams have been running now with ECP funds under our project-based planning for about 2 years now. And so we're beginning to see some fantastic results roll out. It's not like they weren't there in the first 3 to 6 months, but 2 years is really kind of a good time to say, let's see how we're doing. And in terms of applications, there are really two measures. Are they addressing their challenge problem? Are they on track to address their challenge problem, which is a problem that's intractable today? It's a problem that requires exascale resources, and it's a problem that a DOE program office sees as a strategic one we should address. And the second is, in addressing that problem, are we making good use of the resources? Are we really on a good performance track? This ExaSMR project really hits both really well. So they're after a next generation parallel Monte Carlo capability for the neutronics, which are essentially the neutron state of a reactor, which is key. And the way they're going to do that is with trillions of particles, trillions of Monte Carlo particles. The error bars, if you want to call it that, really shrink with more particles. So with Exascale, this team is after trillions, in this case 50 to 100 trillion particles for a full reactor. And what that maps into is a very, very small error bar on the result. In fact, the neutronic state of the reactor could arguably be, if the cross sections are correct in the simulation, almost as good as experimental data. So Monte Carlo simulations are essentially the gold standard, okay, in this community. So they're on track to do this with their app codes called Shift from Oak Ridge and OpenMC from Argonne. They're showing that they're on a great track. In fact, I think the recent interesting the metric for the Shift code on Summit is already kind of 200 million particles per second. And I think they're on good track for the sort of 50 to 100 trillion particles. So the performance is there. They've really done well. I think this team is really ahead of some of our other teams, frankly, in mapping their models and algorithms onto the GPUs. In this case, what they've done is really figured out how to deal with conditional branching and parallelize that and put it on the GPU in a way that's effective. So there are performance numbers, as noted in the highlight that's on our website, really are fantastic, and you're going to see customers really take advantage of this. The Office of Nuclear Energy, or NE as we call it, is a key customer, but I think you're going to see everything from startups to key nuclear vendors take advantage of this technology to really be able to do designs on the computer and to move the experimental paradigm from exploratory to confirmatory. Okay, so we can pretty much nail that design with tools like this, and we're going to go confirm with an experiment. That's gonna we think take this licensing. We want to see the licensing timescale really shrink down to where we're able to build and deploy these reactors much quicker and with much less expense. So it's a key project, I think, for the nation and obviously for ECP.
Got it. Cool. And we'll probably be hearing a lot more about ExaSMR as we go forward.
I think so. It's a great team.
Cool. So Doug, that kind of leads into the topic of performance measurement. Yeah. The project seems to be spending a lot of time digging into performance measurement reports and so forth. What's the big deal with that? Why is it so important?
Yeah, so in this case, performance for the HPC crowd here isn't performance on a large computer like Summit. It's performance in terms of, is your project performing? Are you executing? Is your plan the right plan? And are you executing according to that plan? And so performance in this sense means we have precious taxpayer dollars. Are we doing the right thing with those dollars? So we'll call that cost performance. Are we meeting our milestones on time? Okay, and that's schedule performance. And then if we're not, what's the variance there and why? Can we explain it? And if there is a variance that we don't like, can we act on that information and improve it? So the performance measurement here is very important for us. We do have a review coming up on how we've married essential agile methodologies, which we firmly believe in for software development. I think the data shows that agile development approaches are the way to go for software development activities, and a lot of ECP is right in that space. So our review next week is very important. It's an internal review where we're going to have a group of experts from industry, from DOE, from academia. You take a look at how we're marrying agile and traditional project management. Our measurement is our approach for measuring progress reasonable and appropriate? Is it going to shine the light on where we have problems or where we don't? In particular, we want to be able to understand we have an issue here, we've got to address it. So we're looking at how we're using the data, how we're working with our PIs. Overall, I feel really good about what we've done. I think in many cases it's very unique, and I think we're a pathfinder there. Not that we figured this all out and everything we're doing is perfect, but as we move into our next phase about a year from now, which will really be more product deployment, we're certainly building products now and deploying them, but as we move in that next phase, our ability to measure performance and correct it quickly so we meet our goals and key performance parameters is crucial. So I feel really good about where we are there. I think in many ways I think almost any way you slice it, we're a very unique and complex project. So we have to do this well.
Okay. So we've kind of we've talked about the organization. We've touched on applications. We've touched on software and performance measurement. But let's talk about the third focus within ECP, which is hardware and integration. Maybe you could say a little bit about software deployment as it relates to the hardware and integration focus.
Yeah, it's exciting. So we realized, I guess it wasn't an epiphany, but with Mike Carew and team in software technology coming on board last fall, we realized we're building this 90 plus products, and we realized that we could group them together in sort of common thematic areas called SDK, software development kits. In other words, we'll have one for I/O and data analytics and one for math. And so we realized we can package these products together in what I'll call sort of more bite-sized pieces, and then work with our DOE facilities. And when I say DOE facilities, there are 6 labs that predominantly we're targeting, but in principle, we're interested in deploying beyond that, NSF facilities, DoD facilities, et cetera. But what we're doing now in the software deployment area is we're going to have our first release in Mike's area of our SDK packages, and I think his plans are sort of for 5 or 6. And so this fall, we're going to start pushing those packages for continuous integration and testing into the facilities. And these are production facilities that are international user facilities. So we're not going to go in and just replace a key component that a lot of users use. We need to deploy it in a test sense, integrate it into a test environment, test it, and we call it CI, continuous integration and testing, and get feedback on what's working and what's not, so that we can harden the products for production. And the exciting thing about it is this is really a key aspect of Agile, which is to deploy early and often and get continuous customer feedback. But also, if we were to wait till the Exascale systems come and do that, it's too late. Doing it now gives us a sense on what works, what doesn't, which features are missing, and we'll be able to harden the products for the Exascale systems. I'll also add that if you're a user on one of these facilities, you ought to be able to type module load live-ECP, meaning we're going to have our stuff there for users to alpha and beta test now and give us feedback on is it better, if not what do we need to do to fix it. So exciting. It's a key aspect of the hardware and integration focus area to be that integrating factor to make that final push into facilities. And we've gotten really good interactions, feedback, and commitment from the DOE facilities. So I think we're in much better shape than we were last year with regard to this integration to facilities.
It's awesome. It's been a great update. Thanks, Doug.
Thank you.
And we'll get this out published for the public as soon as we can, and we'll look forward to doing this again with you in a few months.
Great, Mike. Look forward to it. We're excited and always happy to talk. So,
we've been talking with Doug Kothe, the ECP Director for the Exascale Computing Project. I'm Mike Bernhardt.